Hello everyone, I hope you all are doing well. Today we are going to discuss the next topic of the data science course, that is naive-bayes classification. Let's start. Naive-Bayes is a powerful and widely used classification algorithm in data science. It's based on Bayes' theorem, a fundamental concept in probability theory. Fundamental of probability and Bayes theory. Probability basics. Probability quantifies the likelihood of an event occurring. Bayes theorem. Bayes theorem calculates the conditional probability of an event given prior knowledge, prior and posterior probabilities. Prior probabilities represent initial beliefs, while posterior probabilities are updated based on new evidence. Prior means before the analysis, and post means after the calculation, the analysis that is done. Applying naive-Bayes to classification problems. Predicting class labels. Naive-Bayes assigns data points to categories based on their features. So the data that we are using, the the categories assigned to that data is based on their features. Feature independence assumption. The algorithm assumes features are independent of each other. The data points that are categorized on the basis of features previously. So the name base that Bayes theorem assumes that the features that are on the basis of which we have categorized our data are independent of each other. The features are not dependent on each other. Conditional probability calculation. It calculates the probability of each class given the features of a data point. So, in first part, we categorize that data points, and the theorem assumes that those features are independent of each other. Then it calculates the probability of each class. So we divided those data points on the basis of on the basis of features. We divided the data points in different categories. So we calculate the probability of each category. It calculates the probability of each class. Here, that category is known as class, given the feature of a data point. As we divided with the help of feature, so we calculate the probability of the each class or each category according to the data points, and according to the features we have divided those data. Advantages and limitations of Bayes. Advantages: simplicity and efficiency. It is simple and efficient. Anyone can. It is easy to understand. Anyone can understand it easily and efficiently can use it. Robustness to noisy data. What basically noisy data is? Too much data. Where there is too much data is provided for the analysis, that is included in the noisy data. So what basically Bayes theorem does, it easily handles the noisy data. Means where too much data is provided to us, we can easily apply theorems and analyze those data. Effective for high dimensional data sets. High dimensional data set means the which is very high data. Limitation: feature independence assumption. In the last slide we discussed feature, what a feature, and on the basis of how the data is divided. So that is the limitation, that feature independence assumption, that the features on which we are dividing the data points are independent of each other. It is the one of the drawback of the Bayes theorem. Sensitivity to zero frequency problems, can overfit in small data sets. It can be applied to small data sets also. That is the limitation. That yes, it is helpful for the noisy data and too much data, but it is also helpful for the small data set. That is considered as it one of the drawback of it. Real world application of Naive-Bayes. Spam filtering, identifying and blocking spam emails based on content pattern. This is one of the basic example, as we can see in our mail section also. Our mails are divided into spam and not spam. Do we have divided? No, we have not divided those mails, but it is done by itself by Gmail. It divided makes a group of mails that are spam and that are not spam. So it is done by uh, with the help of Bayes theorem. Sentiment analysis, determining the emotional tone of text data such as reviews or social media posts. Medical diagnosis, assisting in diagnosing diseases based on patient symptoms and medical history. On the basis of the patient medical report and what all problem the patient had, the new medicine should be given on the basis of that. If already some of the medicines of that patient is going on, so if more medicines of that dose is given, it will create problem for the patient. So on the basis of the medicines he or she is already taking, the patient is already taking, the medical history or the symptoms he is suffering from that problem, on the basis of that, new medicine or new prescription to that patient is given. How this analysis is done, this is also done by with the help of Bayesian recommendation system, suggesting products or services based on user preferences and past behavior. It is mainly useful in sales that some surveys are done, and we see that they suggest us some products. So how they get to know the uh, or how we choose the new items on the basis of our choice what we have previously used. Thank you. I